Hello everybody and welcome to lesson 15 transportation problem optimum solution. In the previous lessons, particularly in lesson 13, we have discussed about the feasible solutions of, or we can say the initial feasible solutions of transportation problem, and we solve it using three techniques that are the northwest corner, the minimum sale cost method, and Vogel's approximation method. We have used those three methods to find out the initial feasible solution. And in lesson 14, we have also discussed about, or we have also find the solutions of the unbalanced transportation problem by adding dummy variable. And here in lesson 15, we will find the optimum solution, that means the last solution, or we can say there is no more better solution. There is no better solution than the optimum solution. So here we will find the optimum solutions of the transportation problem using UV method. The learning objectives of this lesson is finding the optimum solutions of balanced transportation problem using UV method. By the way, as I said in the previous slides, the method of finding initial feasible solutions are three that we have discussed in lesson 13 and lesson 14. The first one is northwest corner method, the minimum sale cost method, and Vogel's approximation method. This method only finds the initial feasible solution. So to find out the optimum solution, we have to use UV method based on or just starting from the initial feasible solution. Let's move to the steps of UV method. First, we have to check, the first step is we have to check m plus n minus 1 equals number of allocated cells. That means the result that can be obtained from the initial feasible solution, or the results that can be obtained from either of the three methods, that is either northwest corner or minimum sale cost or Vogel's approximation method. So m plus n minus 1 equals number of allocated cells, where m stands for number of rows and n stands for number of columns. So the number of row plus the number of column minus 1 should be equal to number of allocated cell to use UV method. So we have to check this first. And the second is we have to find out UI plus Vj equals Cij by assuming that U1 equals 0. U1, by the way, U1 corresponds to or allocated for the rows, and where Vj is allocated for the columns. Anyway, we will see with examples what UI and what Vj represent us. And the third one is check optimality if Eij greater than or equal to 0, where Eij equals Cij minus Ui minus Vj. By the way, Cij is the per unit cost, for non-allocated cells. Let me say something about those concepts. For each unoccupied cell, Eij equals Cij minus Ui minus Vj provides the change in total cost per unit that will be obtained by allocating 1 unit of the flow to the corresponding arc. The net valuation index, by the way, this index Eij for each occupied cell equals to 0, whereas for the non-occupied cell, the positive value of Eij means which increases the cost if we allocate to that particular cell. So the positive value means it increases our cost, our total cost, and the negative value of Eij means it decreases the per unit cost. Hence, we have to allocate to the cells that decrease the cost. That means we have to allocate to the cells that have the negative value of Eij. If all Eij are positive or become positive, so no more per unit cost reduction is possible, or optimality is already achieved. So no further reduction can be possible, so optimality is already achieved. So we have to stop there. Let's see this example. By the way, this example is a previous example that we have solved in lesson 13 and 14. So using northwest corner method, we have already solved this transportation problem. So basing that or using that as a starting point, so we have to go for finding the optimal solution for this transportation problem that we already solved, that we already obtained the initial feasible solution using the three methods: the northwest corner, the minimum sale cost method, and Vogel's approximation method. Then, as we remember, the northwest corner method provides this. The northwest corner method provides this result, and we get as an initial solution, as an initial feasible solution, 2250. So based on this, starting from this, let's go for finding the optimum solution for this transportation, for this balanced transportation problem. So here is the result for the northwest corner method. So step one, as we discussed in the previous slide, is to check whether n plus m minus 1 equals number of occupied cell. Now let's count this. 1, this is an occupied cell. 2, 3, 4, 5, 6. So the number of occupied cell is 6. And we have 1, 2, 3, 4 columns plus 1, 2, 3 rows. 4 plus 3, 7, 7 minus 1, 6. 6 is the number of occupied cells. So the first criteria is fulfilled, so we can go, we can use UV method to find out the optimum solution of this transportation problem. And the next step is find the UI plus Vj equals Cij for the allocated cell by assuming that U1 equals 0. U1 equals 0. By the way, these are U1, U2, U3, and V1, V2, V3, V4. So, and the Cij are the per unit cost, Now, we will calculate for the allocated cell only. So let's assume that U1 equals 0. Here we have to set U1 equals 0. And let's find out V1, which is corresponding to the allocated cell. So U1, that is 0 plus V1 equals 50. So V1 becomes 50. V1 becomes here, it becomes 50. And the next is, let's find out V2. U1 plus V2 equals 75. So from this, we can say that V2 equals 75. V2 equals 75. Okay, now let's go for finding U2 because we are not calculating for the non-allocated cell. So let's calculate for U2 in this case. U2 plus 75, here we have 75, U2 plus 75 equals what? 80, so U2 becomes 5. U2 becomes 5. Okay, and 5, that is U2 plus V3 equals what? 40. So V3 becomes 35. V3 becomes 35. Okay, and V3 for this allocated cell in the row 3, U3 plus 35 equals 50. So U3 becomes 15. 15, right? 15. Okay, and U3, that's 15 plus V4 equals 55. What is U4? V4 becomes what? 40. V4 becomes 40. This is step 2, and we already find out the U1, the UI and Vj by the equation of UI plus Vj equals Cij, and by assuming U1 equals 0. And the next step is to find out the Eij for the non-allocated cell. By the way, step 3 is for the non-allocated cell. So we have to find out Eij for the non-allocated cell and choose the maximum negative from Eij. So to find out Eij equals Cij minus Ui minus Bij, we already know that. By the way, this one is non-allocated, so this one is E1 3. This one is E1 3. This one is E1 3, and this one is E1 4, E1 4, and this one is sorry for the clearness, E2 1, here it is E2 1, and this one is E2 4, and the next is this one is E3 1, E3 1, and this one is E3 2. So we have to calculate for these values, and we have to choose the maximum negative. That means the maximum negative of E value decreases the total transportation cost when we allocate the items to be transported to that particular cells. So we can calculate E13 equals Cij means 30 minus 0 minus 35. So we can get minus 5. And for E14, 45 minus 0 minus 40. And for E21, 65 minus 5 minus 50. And for E24, we can calculate 60 minus 5 minus 40. And for E31, 40 means this one, 40 minus 15 minus 50, we get minus 25, and E32, 70 minus 15 minus 75. So we get minus 20. From this Eij value, minus 25 is the maximum. So here we have to point out E32. This one is our initial cell. Our initial cell that can minimize the transportation cost. So from this, we have to draw a closed loop starting from this. Now let's go to the closed loop which starts from this, and let's move like this. Here we go from this. Here we go to here, and let's go up. By the way, we are using those allocated cells as a stepping stone in the corner points. So from here, we have to start from E31 because E31 is a maximum negative, right? So we have to start from E31. Let's remove this one. So we have to start from E31 because, as you see here, E31 is the maximum negative value, right? E31 is the maximum negative value. So we have to start from here, and we have to go to the next allocated cell that become the corner stepping stone. So we have to go here. We have to go, for example, we can go like this. By the way, if we continue, we cannot get a turning allocated point. So we have to turn like this. And using this allocated cell as a stepping stone, let's move to this. Now we can turn. From here towards above, following the allocated cell. Now we can turn like this, and now we return back to our original point, right? So here is a closed loop constructed on the stepping stone. That is, the stepping stones are the allocated cells found in the corner points. Now we have to provide a positive sign for this initial. Let's make it this one positive sign, and then alternatively we have to give for this negative sign, then positive sign here, then negative sign, and then positive sign here, and now let's provide here negative sign. And from the negative signs, that means from the negative signs, we have to choose the minimum one. There are 3 negative signs: negative here, and negative here. So from this, here we get 10, and here is 8, and here is 1. So we have to choose the minimum one, that is 1. We have to choose the minimum one, that is 1, and we have to add on the addition sign, and we have to subtract on the minus sign. Now here there is subtraction, or there is minus sign, so we have to subtract 1. So we eliminate here, we eliminate this one, and we have to add 1 here, so it becomes 10. This one will be 10. This one will be 10. And here there is minus sign, so we have to add this 1 to, we have to subtract 1 from 8. So we have to cancel this one, and we have to write 7 because we subtract 1. And here there is addition, so we have to add 1 on 2, so it becomes 3. And the next is here, there is minus sign, so we have to subtract 1, so it becomes 9. Okay, and here there is addition or plus sign, so we have to add what? We have to add 1. We have to add 1 here. We have to add 1 here. So we already finished now the first iteration, and the next iteration is to repeat this step, starting from step 1 to 3. So here what we have changed is this cell become no more allocated cells, and this cell becomes allocated. We allocated for this cell. So, by the way, using northwest corner, we got the total transportation cost. The total transportation cost 2,250. So, for the optimum solution, we have to get a value which is less than this cost. So, this is the new table. The new table with the new allocation as we previously calculated. So now let's again calculate. First, let's check the optimality. So because we have already 4 column and 3 rows, so 4 plus 3 equals 7 minus 1 becomes the allocated cell. Still the allocated cells are 6. 1, 2, 3, 4, 5, 6. And the next step is to find out what? Find out UI plus VJ equals CIJ for the allocated cell by assuming this one 0. This one. If we make this one 0, V1 becomes 0 plus V1 equals 50, so it becomes 55, right? And for this cell, 0 plus 75 equals 75, 0 plus V2 equals 75, so it becomes 75, right? 75, and the same procedure applies for the remaining allocated cell, and we get U2 2, 5, U10, U3, 10, and V3, 30, and V4, 35. And the next is find the Eij equals Cij minus Ui minus Vj for non-allocated cell, and we have to choose a maximum value. Here the non-allocated cells are, this one is E1 3, and this one is E14, right? This one is E14, and this one is E21, and this one is E2, E24, and this one is E3, 2, and this one is E33, 3, E33. Then we have to find out this value by this equation. By this equation we have to find out, and the result become like this. Among this value we have to choose the maximum negative, that is minus 20, and the corresponding cell is E14, that is E14 becomes this one. This one is E14. So starting from this non-allocated cell, we have to draw a closed loop using the allocated cell as a stepping stone, as a stepping turning corner. So from this, let's move to the next stepping cell. The next allocated cell, that is here. Here we go. We can go like this. We can go like this one, and the next is we can go like this, and here we go, and the next is we can go like this, and we can return back to our origin, our initial point. So this is the closed loop, and we have used the corner points as a stepping stone, the corner, or we have used the allocated cell as a stepping stone in the turning point. Now let's start our plus minus assign. So let's start this one plus, and here minus. By the way, we only assign the plus minus on the turning point, so this one is minus, and this one become plus, and this one become minus. So let's compare the minus sign. Here we have 9, and here we have 10, and 9 is less than 10, so we have to subtract 9 from the minus, and we have to add 9 on the plus signs. So here 9 minus 9 becomes 0. Here we already cancel out, and here when we add 9, this becomes 10. This becomes 10. 10 item is allocated for this cell, and when we minus 9, because here is a minus sign where we minus 9, so the remaining becomes 1, already 1, right? Already 1. So when we subtract 9, the remaining is 1. And we have to add here, because it's a plus sign, so we have to add 9, right? Here it becomes 9. So the allocated cells are changed, right? So the allocated cells are changed. This cell is no more allocated, and this cell is allocated, and we have to start with this new allocated table, we have to start the steps, the procedures again. By the way, here in this new table, the cost starts to decrease, right? We get at least we can minimize with this step, even at least we can minimize with 25. We can minimize starting from the northwest corner, we can minimize 25. This is the table, the new table with the new assigned cells. So let's start step 1. We can check n plus m minus 1 equals the number of occupied cell, and the second is ui plus vj equals cij for the allocated cells by assuming u1 equals 0. So let's find this one, u1 0 plus 75, u1 0 plus v2 equals 75, so v2 equals 75, and 0 plus v4 equals 45, so v4 becomes 45. And using the same procedure, we can get for the u1, u and v value for the allocated cells. And now, step 3, we have to calculate now eij for the non-allocated cells. Here, the non-allocated cells are here E11. E11 is non-allocated cell, and here E13 is non-allocated cell, and here E21 is non-allocated cell, and the next here is E24 is non-allocated cell. E24 is non-allocated cell, and E32 is non-allocated cell as well, and E33 is another non-allocated cell. So we have calculated the E values using Cj minus Ui minus Vj, and the maximum value is minus 15, which is the corresponding cell is E32. So using E32 as a starting point, let us draw the closed loop. So from here, we can move like this, and we can move like this, and we can move like this, and we can return back to this. By the way, if we go like this and we go like this, there is no turning point. There is no allocated cell which is used as a turning point. So we have to turn on the allocated cells. It is only possible to turn on the allocated cells. This is the principles of drawing the loop, right? So let's assign the signs here. Let's add a plus sign. Here we have to start from plus, here minus, here plus, here minus. Now let's compare the minus sign value 3 here we have, and here we have 1. So 1 is less than 3. So let's add 1 on the plus sign and subtract 1 on the minus sign. So here it becomes 0 when we subtract 1, right? And here when we add 1, it becomes 10, right? Here it becomes 10. When we add 1 on 9, so it becomes 10, and we subtract 1 from 3, so it becomes 2. And here we have to add 1, and we get 1 item allocated here. So as you see, the cells are already allocated, right? The new cells are allocated. And in this step, by the way, if we calculate the cost even further decreases from the previous step. With each iteration, the costs become approaching to the optimal solution, right? so we further decrease to 2065. And now let's move to the new table with the new assigned values. So this is the new table with the new assigned value, and now let's check the n plus m minus 1, and the next step is we have to find u I plus vj equals cij for the allocated cells. We have to find out by assuming that u1 equals 0, u1 equals 0 plus v2 equals 75, so v2 equals 75, and here it is v4 equals 45, and using the same procedure we can calculate u2, u3, and v3 and v1. And the next step is to find out the EIJ value, and we have to choose the most negative value. And the EIJ is, by the way, then for calculating the EIJ we have to calculate from the non-allocated cell, right? Non-allocated cells. The non-allocated cell here is this one. This one is E11. This is E11 is a non-allocated cell. Here it is another non-allocated cell, which is E13, and the other is E21 is another non-allocated cell, and here it is E24, another non-allocated cell, and the other is E3. E3 is another non-allocated cell. Sorry for the clearness. And the other is E34. So we have to calculate this cells value of EIJ. So when we calculate the values, so we get this, and the maximum negative value is only -5, and the corresponding cell is E13. This one is our initial point. This one is our initial point, and using this as an initial point, we have to draw a loop. So it's possible to draw, by the way. We cannot draw like this, because if we turn like this, and we cannot get a turning point. And let's try with this direction. So here we can turn here and turn like this. Sorry for the lines. Let me omit. Okay, so let me draw it again. Starting from here, we can draw like this, and we can draw like this, and we can turn like this, and we can turn to our initial points. So let's assign the plus and minus signs. Starting from here, let's assign here plus sign, and here minus sign, and here plus sign, and here it is a minus sign. So from the minus sign, here there is 2, and here there is 10. So 2 is less than 10. So let's add on the plus sign. Let's add 2 on the plus sign and subtract 2 on the minus sign. So we have to subtract the 2 from this, and it will be cancelled just. And we have to add here. The 7 plus 2 becomes 9, and we get 9 here. And here subtraction, we have to subtract 2, and it becomes 10 minus 2, it becomes 8, right? 8. And from here we have to add 2. We have to add 2, so we get here 2. So we get here 2. So now let's create new table with the new assigned cells. As you see, the cost is further decreases from the previous iteration cost, right? Now it becomes 2030. Let's move to the new table. The new table with the new assigned value. So now let's again calculate the first let me check that n plus m minus 1 equals the number of occupied cells. So it achieved, and step 2 is find the u and v value using the equation ui plus vj equals cij for the allocated cell by assuming that u1 equals 0, so we can get u1 equals 0 and 0 plus v3 equals 30, so v3 becomes 30, and 0 plus v4 equals 45, so v4 equals 45. And the same is true for the remaining steps. Now let's find out the eij by this equation, Cij minus ui minus vj for non-allocated cell. The non-allocated cell, this one is E11 is one allocated cell, and E12 is another non-allocated cell. E21 is another allocated cell, and here E24 is another allocated cell, and here we get E3 what? For E33, sorry, E33. Here it is, E33, and the other is E3. By the way, the first subscript represents the rows, and the second represents the column, right? So this one becomes 4, the fourth column, it means. So when we calculate the eij value, we get the eij value. All the eij value becomes positive, right? As you see, all the eij value becomes positive. So there is no more cell which can reduce our overall per unit cost. There is no more cell. So we have already achieved our optimality. We have already achieved our optimalities. Then now let's calculate the total costs using these allocated cells. So the total cost becomes like this: 30 times 2 plus 45 times 10 plus 80 times 9 plus 40 times 8 plus 40 times 10 plus 70 times 1 equals 2020. This is the optimal solution, and obviously it should be less than the initial feasible solution. The initial feasible solution obtained by the using least cost method is 2065, and using northwest corner is 2250, and even the initial solution using Vogel's approximation method is 2030. So all the initial feasible solutions are greater than the optimal solution. So our optimal solution is less than the others or the initial solutions. Let me add you one last tip. By the way, the optimal solution, the initial solution, which is obtained by the Vogel's approximation method, is better or near to the optimal solution. So if we have the value, if we have the initial feasible value obtained by Vogel's approximation method is, so it is better and it is advisable to start from the Vogel's approximation method to decrease the number of iterations to arrive on the optimal solution. As we discussed in the previous slides, it takes a long time to arrive on, it takes many iterations to arrive on the optimal solution from the northwest corner result. But if we start from the result of Vogel's approximation method, so it takes only one iteration to arrive on the optimal solution, because the result of the Vogel's approximation method is nearer or closer to the optimal solution than the northwest corner method. Let me check. This is the result obtained from the Vogel's approximation method. This is the initial solution. So if this is the initial solution, and if we are required to calculate the optimal solution starting from this result, let's check the optimality. Let's check n plus m minus 1 number of occupied cells. It's already fulfilled, and let's proceed to find out ui and vj using this equation. So we get like this, we get already like this, and now let's calculate the non-allocated cell eij for the non-allocated cell, and here we go, we get the -5, and -5 is E13. E13 means E13 is on the first row and third column. Here it is our initial cell. So from here we have to go to like this and like this and like this and like this. So let's add this one. Let's have plus sign, minus sign, plus sign, and here minus sign. Let's compare the minus sign, that is 2 and 10. 2 is less than, so we have to subtract on the minus sign, and here we have subtracted, and here we have added 2, and here we have to subtract 2 from 10, so we get here 8, and here we have to add 2 on 7, it becomes 9, right? So here it becomes 9. Now let's move to the assigned cell, the new assigned cell. So the new assigned cell is this one, and let's check the n plus m minus 1, and it's fulfilled. So let's find out ui and vj using this equation, and let's find eij. So as you see here, all eij values are positive, so we have already achieved our optimality. Look, by the way, the difference between calculating the optimal solution starting from the northwest corner method result and starting from the Vogel's approximation method. This iteration, or starting from the Vogel's approximation method, or finding the optimal solution starting from the Vogel's approximation method, takes less number of iterations than starting from the northwest corner method, because northwest corner method result is far from the optimal solution, whereas the result of Vogel's approximation method is closer to the optimal solution. So it is highly advisable to start finding the optimal solution from Vogel's approximation method result. This is just a tip. So the final solution for the optimal solution is 2020. This is all about today's discussion, and we will continue with the other lesson next time. Till then, have a good time. Bye.